Okay, so we're going to start getting all the zeros of a polynomial function. And pardon me if I sound a little bit rushed. This is my second take of this video because the first one didn't work. So it's probably not going to be as good, but we're going to just go with it anyway. So what I want to do here is I want to get all the roots of a polynomial function. Now up above, we talked about getting all the roots, using the calculator. We were able to get all the roots in the calculator using the intersect feature and talking about what a multiplicity is and how to get the zeros from the factors. Well, in this case here, as you're going to see when you graph it, you're not going to get all the zeros because we need to have 3 zeros. According to the fundamental theorem of algebra, since that exponent's 3, we need to have 3 zeros. So graph it. Graph and find real zeros, however many there are. So if there's 1, then find them. If there's 2, find them. If there's 20, find them. So whatever there is, that exponent, there could be up to 3, but we can't guarantee there are 3. So we'll graph it and put that in y1. I should clarify, there's going to be 3 zeros, but we can't guarantee they're all going to be on the graph. Okay? So y1, 0 in for y2. All right, and so what I look at there is it looks like it crosses at -2. We're going to verify that by using the intersection. So second trace 5. Enter, enter, enter. And that zeroes at -2. So we have real 0, -2. But how do I get the other 2? Well, this is where we have to use, this is going to be 2 complex solutions. So since there's 1 real, there's going to be 2 complex. And a complex solution cannot be solved using the graph on a calculator. It has to be solved by hand. What we're going to do is we're going to use synthetic division. So this is kind of step 2, synthetic division. We're going to put that -2 in a box. And to get the numbers for synthetic division, we'll line up our coefficients. So we have 1, 2, 4, and 8. Make a line down below. You know how to do this, so I'm not going to spend a ton of time. Just bring that 1 down. Multiply. Add. Multiply. Add. Multiply. Careful with your signs. Use your calculator if you need to. Add. That's your remainder. Our remainder has to be 0 because guess what? X plus 2 is a factor. Why is x plus 2 a factor? Because we already have the 0 as -2. And remember, the 0 and factor have opposite signs. So essentially what we're doing is we're plugging in the 0. Get this to zoom. We're going to plug in the 0 to get a different expression with a remainder of 0. Now what this is going to be is it's going to be a quadratic. You can always have a quadratic for these because, we're coming down from a 3. So it's going to be 1x squared, 0x, and 4. Well, what is that expression really? It's going to be just x squared plus, we don't have to write 0x, so x squared plus 4. And then if I want to find the zeros, I'm going to set it equal to 0. So x squared plus 4 equals 0. Well, how do we solve this? Take away the 4. And you get -4. So negative 4 can't be square rooted in traditional sense, okay? I can square root 4. If you try this, you need square root 4, you know that's going to be 2. But if I say the square root of negative 4, we're going to get a big fat error. And that means there's no real answer. But there is an answer to that, okay? So you might remember that the square root of a negative number has some complex solutions. Let me just refresh you on what a complex number is, okay? There's going to be this little imaginary number called I, and that stands for the square root of 1. So if we define I as the square root of 1, then what I can say is, if I take the square root of both of these sides, and I'm going to put a plus or minus, because remember, you can square root to get a positive and square root to get a negative. I can say the square root plus or minus the square root of negative 4. Now I can break that negative 4 down into 4 times negative 1. Okay, well, I know the square root of 4 is 2. That's going to be plus or minus 2. Now, what is the square root of negative 1? That's I. So 2 times I. And that's actually my complex answer. Okay, so these are my complex zeros. Plus or minus I. Now, where's the third zero? That's 2 of them right there. 2 zeros. Why is there 2? Because one's a positive and one's a negative. So along with this, that constitutes my 3 zeros, okay? So all my zeros are going to be x equals negative 2, positive 2i, and negative 2i. All those are zeros. It's kind of weird, but that satisfies the need to have 3 zeros due to that third power. We can actually check that. Let me show you something in here that's kind of cool. I want you to hit the mode button. Scroll down to where it says real and go over to a plus bi and hit enter. Okay, that should highlight that. It's in a complex mode. And now if you actually do the square root, second x squared, square root of negative 4, you can get 2i. Now it's not going to give you a plus or minus symbol, but it'll at least give you the I with it. So you can kind of associate that plus or minus with it. We can check our numbers. We can plug in. We could plug in our real zero, so negative 2. If I plug it back in, I get negative 2 to the third power plus 2 times negative 2 squared plus 4 times negative 2 plus 8. That's 0. If I plug in positive 2i, well, how do I get I? Right down there, second point. So I can plug in positive 2i. Get 0 that way. And I can do the same with negative 2i. All 3 of those get me 0, so they are my zeros for this polynomial expression. Okay, pause the video, flip to the back side, start getting the zeros from the calculator, and I'll meet you up on the other side. Okay, so obviously the first thing we want to do is get the real zeros. So we're going to go ahead and plug that in. Y equals, keep the 0 in for y2, put that in for y1. Graph it, see where it intersects the flat line at 0, which is the x-axis. Give it a minute. It's slow. All right, second trace 5. Scroll to the right. Oops. And then 3 enters, enter, 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 2. So my real 0. And that's from the graph. Now we got 1 out of our 3 zeros. That's the third power again. So in this case here, it's going to be a little bit different. We're still going to do the synthetic division. So we're going to say 2 in the box, 1, negative 12, 46, and negative 52. Now we got some bigger numbers here, so just be careful. Use that calculator. Let's go through and do the synthetic division. In fact, try to pause it, see if you can do it here. A little more practice, you know? It's good for you. I'll wait. You pause it. Try it on your own. All right, check my work. 1 times 2 is 2. Negative 12 plus 2. Negative 10 times 2. Negative 20. 46 plus negative 20 is 26 times 2. 52. Remainder 0. So that's going to be 1x squared minus 10x plus 26. 1x squared minus 10x plus 26. How do I solve that? I'm going to say x squared minus 10x plus 26 is equal to 0. And then I'm going to have to use a different technique for this one because I have a dreaded middle term in there, and I can't just subtract 26 and take the square root. What do I do with that? So what we're going to do is the quadratic formula. Quadratic formula. Here's how you do it. Write this down. Even if you remember it, it's good practice. So the quadratic formula is x equals the opposite of b plus or minus square root b squared minus 4ac, all of that divided by 2a. What is a, b, and c? A is 1, b is negative 10, c is 26. So we're going to plug that into the formula, and that'll get us some zeros. Hopefully you remember this from math 2. So x equals the opposite of negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times 26, all divided by 2 times a, which is 1. That looks pretty complicated, but we can simplify that. So opposite of negative 10 is positive 10. What's all this? Well, let's put it in the calculator. Use parentheses around everything. Negative 4. Oh, good. Negative 4. All over 2 times 1 is 2. Now, you might remember the square root of 4 is 2, and the square root of negative 4 is 2i. If you are in a plus bi mode, you can double check that. The square root of negative 4 is 2i. So we're going to say 10 plus or minus 2i over 2. But wait, these are both divisible by 2. So what's going to happen when I do that? 10 divided by 2, that's going to be 5 plus or minus 2i divided by 2, that's 1i. These are your complex. X equals 5 plus or minus I. So again, where are my 3 solutions? Well, my zeros are x equals 2 from up there, x equals 5 plus I, and x equals 5 minus I. All those are my zeros. Okay, I'm going to do example 6 in a separate video so as not to make this one too incredibly long. So hopefully this makes sense, and you can go back and double check the work on the video and if you need to fill anything in. Thank you for watching.